Imagine a perfectly smooth surface. No bumps, no variation, no direction. Everything is uniform. In such a world, nothing interesting happens. Now introduce a tiny disturbance. Fluctuation. A break in uniformity. Suddenly, structure appears. This is the story of the universe. And it begins with symmetry. In physics, symmetry does not mean beauty in the artistic sense. It means invariance. A system is symmetric if it remains unchanged under certain transformations. If you rotate a perfect sphere, it looks the same. That is rotational symmetry. If the laws of physics work the same today as they did yesterday, that is time symmetry. Symmetry means stability under transformation. Now here is the strange part. The universe, at its most fundamental level, appears to begin in symmetry. High-energy states, like those just after the Big Bang, are often described as highly symmetric. Forces that appear distinct today may have once been unified. As the universe cooled, that symmetry broke. And when symmetry breaks, structure emerges. Let's go back historically. In the 20th century, physicists began to realize that symmetry was not just aesthetic, it governed physical law. Emmy Noether, one of the most profound mathematicians in physics, proved something extraordinary. Noether's theorem states that every continuous symmetry corresponds to a conservation law. Time symmetry corresponds to conservation of energy. Spatial symmetry corresponds to conservation of momentum. Rotational symmetry corresponds to conservation of angular momentum. This means that symmetry is not decoration. It is structural necessity. But here's where things become fascinating. If symmetry governs conservation, what governs change? Broken symmetry. Imagine balancing a perfectly round pencil upright on its tip. In principle, the system is symmetric in all directions. There is no preferred direction for it to fall. But once it falls, symmetry is broken. A specific direction is chosen. Structure appears. This is called spontaneous symmetry breaking. The underlying laws remain symmetric, but the state of the system does not. This concept became central in particle physics. In the 1960s, physicists trying to understand why particles have mass proposed something radical. Perhaps the universe is filled with a field, now known as the Higgs field, that is symmetric at high energy, but settles into a lower energy configuration that breaks symmetry. When that happens, particles interacting with the field acquire mass. The Higgs field is not just another field. It represents a universe where symmetry breaking gives rise to structure. Without symmetry breaking, there would be no differentiated particles, no atoms, no chemistry, no biology, no you. Uniformity would persist. Broken symmetry is what makes diversity possible. Now pause and consider the philosophical implications. We often associate symmetry with perfection, balance, harmony. But in physics, perfect symmetry can mean stagnation. It is asymmetry, the breaking of uniformity, that generates form. In cosmology, small quantum fluctuations in the early universe were amplified through cosmic inflation. Those tiny asymmetries eventually became galaxies, stars, planets, life. Without initial imperfection, there would be no structure. Now think carefully. The laws of physics are symmetric, but the universe we observe is not. It is structured, patterned, differentiated. This tells us something profound. Order does not require uniformity. Order can emerge from broken symmetry, and sometimes must. Now let's bring this closer. In complex systems theory, structure often arises when systems cross critical thresholds. A magnet above a certain temperature has randomly oriented atomic spins. Below a critical temperature spins a line. Symmetry breaks. A direction is chosen. The system becomes ordered. Water above 0 degrees Celsius flows freely. Below zero, molecules lock into crystalline structure. Phase transition. Symmetry breaking. In both cases, the underlying physical laws remain the same. What changes is the state of the system. Now consider identity. You may experience moments of instability, uncertainty, crisis, transition. These feel like loss of balance. But in physics, instability is often the precursor to structure. When a system becomes unstable under certain parameters, it reorganizes into a new configuration. Symmetry breaking is not chaos. It is structured reorganization. The universe did not descend into disorder when symmetry broke. It diversified. It differentiated. It became interesting. Now let's stay rigorous. In the standard model of particle physics, symmetry groups describe fundamental interactions. Gauge symmetries govern electromagnetic, weak, and strong forces. Mathematically, these are described using group theory. Structures like SU3, SU2, U1. These symmetries determine how fields interact. But when the Higgs field acquires a non-zero vacuum expectation value, symmetry is broken. Particles that would otherwise be massless gain mass. This is not poetic metaphor. This is experimentally confirmed physics. The Higgs boson, detected at CERN in 2012, confirmed that the Higgs field permeates the universe. Mass is not intrinsic substance. It is interaction with a symmetry-broken field. So what appears as solid weight is actually relational consequence. Properties emerge through interaction under broken symmetry. Now zoom out philosophically. If structure in the universe emerges through symmetry breaking, perhaps transformation in complex systems follows similar logic. Uniform identity is stable, but undifferentiated. Challenge introduces instability. Instability creates potential reconfiguration. In psychology, development often involves disruption. Old patterns destabilize. New configurations emerge. This is not motivational rhetoric. It is structural logic. Uniformity resists differentiation. Broken symmetry enables structure. Now I want you to think about something subtle. When a symmetric system breaks symmetry, it does not abandon its laws. The underlying equations remain invariant. Only the state changes. In human terms, your underlying cognitive architecture may remain. But the configuration, habits, narratives, priorities can reorganize under new conditions. Symmetry breaking is not destruction. It is selection among possibilities. The pencil falls in one direction. The magnet aligns north. The Higgs field settles into a particular vacuum state. Choice emerges from instability. When symmetry breaks, something subtle but decisive happens. A direction appears. Before symmetry breaking, all directions are equivalent. There is no preference. The system is indifferent. After symmetry breaking, indifference disappears. One configuration is selected. This selection gives the system orientation. In physics, this is not mystical. It is structural inevitability. When parameters cross critical thresholds, temperature, energy density, interaction strength, the symmetric state becomes unstable. The system must choose a lower energy configuration. The laws remain symmetric, but the state is not. That difference between law and state is crucial. The laws of physics do not change when symmetry breaks. What changes is the configuration of the system under those laws. Now consider entropy. Entropy is often misunderstood as disorder. But in thermodynamics, entropy is better understood as the number of microstates compatible with a macrostate, a measure of probability. High entropy does not always mean chaos. It means there are many ways for a system to arrange itself. In the early universe, energy density was enormous, and interactions were unified under higher symmetry. As expansion occurred and energy decreased, phase transitions took place. Symmetry-breaking events gave rise to differentiated forces, gravity separating from other interactions, the strong and electro-weak forces differentiating, eventually electromagnetic and weak forces separating through the Higgs mechanism. Each transition introduced new structure. Each reduction in symmetry allowed new complexity. It sounds paradoxical. Breaking symmetry creates order, but this is not contradiction. It is hierarchy. A highly symmetric state can be uniform, but structureless. When symmetry breaks, diversity emerges. Diversity enables interaction. Interaction enables complexity. Complexity enables life. Now bring this back to systems beyond physics. In biology, symmetry breaking is fundamental to development. Early embryos begin as nearly symmetric clusters of cells. Gradients form. Axes develop. Differentiation occurs. Left-right asymmetry emerges. Without symmetry breaking, there would be no organs, no orientation, no function. In neural development, synaptic strengthening and weakening break symmetry in networks, allowing specialization. In ecosystems, slight imbalances create niches. In societies, cultural asymmetries produce innovation. Uniform equilibrium can be stable but unproductive. Instability introduces possibility. Now let's move toward something deeper. In complex systems, instability is often feared. We associate it with collapse. But instability is also the condition for transformation. When a system is perfectly stable, it resists change. When parameters shift, environmental conditions, energy inputs, constraints, the system may approach a bifurcation point. A bifurcation point is where a system can evolve into multiple possible states. Before that point, perturbations fade. After that point, perturbations amplify. This is the mathematics of nonlinear dynamics. At criticality, systems become sensitive to small influences. This is not metaphorical. It is modeled in equations describing fluid turbulence, magnetic transitions, neural networks. Near critical points, small inputs can reorganize structure. Now consider identity through this lens. If your habits, beliefs, and emotional responses are stabilized patterns reinforced by repeated conditions, then change does not require forceful destruction. It requires shifting parameters, sleep patterns, information exposure, social context, physiological regulation, reinforcement loops. When enough parameters shift, the old configuration becomes unstable, and a new configuration becomes possible. The underlying laws, your neural architecture, biological constraints, remain, but the state reorganizes. Symmetry breaking introduces direction. Before direction, there is equivalence. After direction, there is orientation. This explains something subtle about meaning. Meaning requires asymmetry. If every possibility were equally probable and equally valued, choice would dissolve. Differentiation introduces preference. Preference introduces narrative. Narrative introduces identity. So in a strange way, broken symmetry is the origin of story. The universe did not remain a uniform plasma. It cooled, broke symmetry, diversified. You did not remain an undifferentiated child. Experience introduced asymmetry. Preferences formed. Narratives crystallized. But here is something crucial. In physics, symmetry breaking does not eliminate symmetry entirely. Often, a deeper symmetry remains hidden beneath broken states. Gauge symmetries still govern interactions even after symmetry breaking. The Higgs mechanism does not abolish underlying symmetry groups. It changes how they manifest. This layered symmetry suggests that beneath differentiation lies structural coherence. Applied carefully, this insight suggests that transformation does not require erasing foundation. It requires reorganizing manifestation. Now let's return to entropy. As systems evolve, entropy increases globally. But locally, entropy can decrease if energy flows through the system. Life exists because energy flows from the sun, allow local decreases in entropy. Stars form through gravitational collapse, a local increase in order within a larger entropic framework. Order and disorder coexist. Symmetry and asymmetry coexist. Stability and instability coexist. This duality is not contradiction. It is dynamic balance. The universe is not static perfection. It is structured tension. Now think about fear of instability. Humans often seek perfect symmetry in life, balance without disturbance. But in physics, perfect symmetry at high energy prevented differentiation. It was the cooling, the loss of uniformity, that allowed structure. Instability is not enemy of order. It is pathway to complexity. This does not romanticize chaos. Uncontrolled instability can destroy structure, but constrained instability within lawful systems can reorganize structure. Physics shows that transformation happens within constraint, not outside it. That distinction matters. If you think change means abandoning all structure, it feels terrifying. If you understand change as reconfiguration under law, it becomes navigable. The Higgs field did not violate physics to give particles mass, it followed symmetry principles. Similarly, systems reorganize according to internal logic. Now, zoom out further. Why does symmetry matter so deeply in physics? Because symmetry defines invariance. Invariance defines conservation. Conservation defines stability. But too much invariance prevents novelty. Broken symmetry introduces novelty without abolishing law. This may be one of the most profound structural patterns in reality. Law plus instability equals complexity. Now consider the personal dimension carefully, without drifting into motivational cliché. You are not a static object. You are a configuration stabilized by repeated interaction. If environmental parameters shift, if information flow changes, if physiological conditions adjust, if relational dynamics reorganize, your configuration can shift. Not arbitrarily, not infinitely, but structurally. Physics does not promise unlimited transformation. It demonstrates lawful transformation. That distinction is intellectually honest. Symmetry breaking does not produce randomness. It produces selected structure among possibilities. This selection is constrained by equations. Likewise, transformation in life is constrained by biology, environment, context. But within constraints, orientation shifts, and orientation changes trajectory. When a magnet aligns, it does not become something else entirely. It reorganizes internal alignment. When water freezes, it does not cease being H2O. It changes phase. Phase transition is powerful because it is structural, not additive. No new substance is introduced. The same components reorganize. This is perhaps the most grounded bridge between physics and transformation. You do not need to become someone else. You may need to shift phase. And phase shifts require parameter shifts. Temperature, pressure, boundary conditions. In human systems, those parameters include sleep, stress, information, relationships, habits, reinforcement loops. Change enough of them, and configuration reorganizes. Not instantly, but structurally. Broken symmetry introduced direction to the universe. Direction enabled complexity. Complexity enabled consciousness capable of reflecting on symmetry itself. The fact that you can contemplate symmetry breaking is itself a product of billions of years of structured instability. So when you encounter instability, intellectual, emotional, relational, you are not experiencing anomaly in a perfectly symmetric world. You are participating in the same structural logic that shaped galaxies. This does not trivialize difficulty. It contextualizes it. Physics does not eliminate struggle. It reframes it. Uniformity is simple. Differentiation is complex. Complexity allows meaning. Symmetry breaking is not failure of order. It is emergence of structure. And perhaps the most stabilizing insight is this: the laws beneath transformation remain. In physics, equations remain invariant. In life, underlying architecture remains. Configuration changes. Direction emerges. Structure reorganizes. The universe is not static perfection. It is dynamic asymmetry governed by law. And you are not a fragile object trying to avoid disruption. You are structured activity capable of reorganizing under constraint. Symmetry made conservation possible. Broken symmetry made existence interesting. Understanding that does not give you control over the universe, but it gives you orientation within it. And orientation changes everything.